numerator. So this one equals limit. So let's factor this. So it should be minus 3. This would be plus 1. X minus 3. Now x minus 3 is the common factors. Divide out. So it equals limit 2x plus 1. X approaches 3. This is 2 times 3 plus 1, it's 7. So the limit exists equals to 7. So the function value is defined. Limit of function is also defined, but they are not equal to each other. So the limit of f of x as x approaches 3 not equal to f of 3. So this is the reason that we have discontinued. Now let's graph it. First of all, notice that f of x equals 2x squared minus 5x minus 3 over x minus 3. We'll just simplify it. Equals 2x plus 1 if x is not equal to 3. So we need to graph, let's say y equals 2x plus 1. Make a table, x and y. So 0, we get 1. Let's say 2. 4 plus 1 is 5. 3, you get 7, not included. Okay, this would be enough. Two, 4, 6, 8. Okay, 0, 1, 2, 5. So this is 2, 4, this is 5. 3, we have 7, which is not included. This is 7. It's open. Let's erase this. We don't need those. So the graph is this line. So the line something like goes up to here, continues, and at 3 we have 6. This is the point. So the 6 is removed. So the limit goes to 7, but the function value is 6. So this is called removable discontinuity. So if we change 6 into 7, that x equals 3, we get 7. Then we have a continuous function. Now the question was, what's the reason we have discontinuity? And the third condition is broken. So the limit of f of x not equal to function value at 3. Okay, any question?
So this was discontinuous was the name?
It has a discontinuity, yeah, at
No,
a
that's
equal
yeah.
3. Because the point is removed, right, from the graph. Okay, try something similar to this one. Number 24. How would you remove the discontinuity of f? In other words, how would you define f of 2 in order to make f continuous at 2? Z2 is not in the domain. But first find the limit of f of x as x approaches to 2. In order to make it continuous, they they must exist and must be equal to each other, the limit and the function value. So that's why first evaluate limit f of x approaches 2 equals to what? Now notice that numerator and denominator when x is 2 becomes 0. So that means x minus 2 is a common factor. Limit, this is x cubed minus 2 cubed. This is x squared minus 2 squared. X approaches 2 equals limit difference of cubes over x minus 2, x plus 2. X approaches 2. Now, x minus 2, we can divide out. So you have limit of x squared plus 2x plus 4 over x plus 2 as x approaches 2. And 2 is in the domain, just substitute 2 squared. 2 times 2 plus 4 over 2 plus 2 equals, so 4 plus 4, 8, 12 divided 4 equals 3. So the limit exists equals to 3. So we need to define f of x equals 3 if x equals 2. So f of 2 equals 3. Then we remove the discontinuity. So find the limit. It should exist definitely. and make your function to have the same value for the x equals the discontinuity point. So we'll remove the discontinuity. Okay, any question? Now, so little by little, now for those problems, see it says, which one is that? 25 and 6. Explain using theorem 4, 5, 7, 9 why the function is continuous at every number in its domain. And state the domain. So, which one? Let's take 32. So it's composition of sine, cosine, and sine functions. So if I need to write using those tunes, so I can write the answer the following way. See, using those theorems, they ask you to write 32. F of x is sine, cosine, sine x. Now, sine x is continuous on negative infinity to infinity for all real numbers. Range is negative 1 to 1. Now, composition of cosine sine x. So, cosine x is continuous on negative infinity to infinity, which implies continuous on negative 1, 1, range of sine x. It's going to be continuous. Cosine of sine x has range from negative 1 to 1 again. And we already said sine x is continuous on negative infinity to infinity, parentheses, which implies continuous on negative 1, 1. Domain is all real numbers. It's negative infinity to infinity. So composition of the continuous functions will be continuous. Not much to do here. Number 40. So let's see what number 40 says. Show that f is continuous on negative infinity to infinity. It's sine x if x is less than pi over 4, cosine x if x is greater than or equal pi over 4. Okay. So number 40. Sine x if x is less than pi over 4. Cosine x if x is greater than or equal pi over 4. Now sine x and cosine x are continuous on negative infinity to infinity. So the only problem that can occur should be at the point a equals pi over 4. Because for the rest of the values, sine x is continuous, cosine x is continuous. Now, the question is if those two parts are connected to each other or not. So if there is a discontinuity, it should happen only at this point. So first, f of pi over 4 equals, see, x is greater than or equal pi over 4, it's cosine x. It's cosine pi over 4, which is square root 2 over 2. Now second, we need to find limit of f of x as x approaches pi over 4. But to the left and to the right, it has different rules. Now, limit of f of x as x approaches pi over 4 from the left, which means x is less than. So x is less than, not there, let's put it here. So x approaches pi over 4 from the left implies x is less than pi over 4. X approaches pi over 4 from the right implies x is greater than pi over 4. Okay, so if it approaches pi over 4 from the left, it equals limit sine x, x approaches pi over 4 from the left, equals pi over 4 is in the domain of sine x. We put sine pi over 4, which is square root 2 over 2. Now, limit f of x as x approaches pi over 4 from the right. In this case, the rule is cosine x as x approaches pi over 4 from the right equals cosine pi over 4, which is square root 2 over 2. So the limit exists and it equals square root 2 over 2. And third condition is also satisfied. Limit of f of x, x approaches pi over 4, is f at pi over 4, it's square root 2 over 2. So f of x is continuous on negative infinity to infinity. See, first one means continuous on negative infinity to pi over 4. Second part means continuous on including pi over 4 to infinity, or even if you don't include, it's fine. So it's continuous at pi over 4 also. So these two shows continuous at pi over 4. not this two, sorry. This shows that limit exists. This one shows. This 3 shows it's continuous. Continuous at x equals pi over 4. So we show that from the left, from the right, it goes to the same point. Function value is the same. So the limit exists. Function value exists. They are equal to each other. And on the rest of the intervals, sine x and cosine x are continuous. So f of x is continuous on negative infinity to infinity. Okay, any question? Now, the last part of the session is intermediate value theorem. Okay, so the intermediate value theorem states the following. F is continuous on the closed, necessarily closed interval AB, and let n be any number between f of a and f of b, where f of a is not equal to f of b. Then there exists a number c in AB such that f of c equals to n. Now, as long as f of a and f of b are different from each other, the continuous function, if you draw the graph, it doesn't have any interruption, will take over all the points between f of a and f of b. So that means if you choose any n value, at least at one point c, f of c would be equal to n, but it might be at more than one c. Taken once or more than once. Now, any way you graph it. So this idea we will use to prove that certain equations have solution on some closed intervals. So if n is between FA and FMB, there is a C such that f of c equals to n. Okay, 54. Use the intermediate value theorem to show that there is a root of the given equation in the specified interval. 54. 2 over x equals x minus square root x. Okay, let's show that. So we need to show that this is 54. 2 over x equals x minus square root x has a root in this interval. Now, move everything on one side. Doesn't make difference. So we can move 2x to the other side. We can move the other 2 to the left-hand side. So we need to show that this equation has a root, which means has a 0. For some value of x, it should be 0. Now let f of x be 2 over x minus x plus square root x. Now f of x is continuous on 2 3 closed interval. See, the only discontinuity we have for 2 over x when x is 0, 0 is outside of the interval, and square root x is defined when x is greater than or equals 0. So this function is sum and difference of rational, polynomial, and radical functions, and it's continuous on its domain. So it's going to be continuous on 2, 3. If it 2 equals 2 over 2 minus 2 plus square root 2 equals square root 2 minus 1, it's positive, greater than 0. If it 3 equals 2 over 3 minus 3 plus square root 3 equals, let's say, square root 3 minus, what do we get? 3 times 3 is 9, 7 third, which is less than 0. 7 third is 2 point something, and square root 3 is smaller than 2. So we have f of 2 not equal to f of 3. Now, let n be equal to 0. N is between f at 3 and f at 2. So 1 is positive, 1 is negative. So that means 0 going to be between those two. Now, by intermediate value theorem, all the hypotheses are satisfied. F of x is continuous, f at 2 is not equal to f of 3, and n is between those two. By intermediate value theorem, there is a C in 2, 3 such that f at C equals n, which is 0. But this one implies n is 0 of f of x, which implies n is a root of 2 over x minus x plus square root x equals 0, which implies, not n, sorry, c. C is a root of this one. Here also, c is a 0 of f of x. C is the root of this one, which implies c is a root of 2 over x equals x minus square root x. So first we construct a function, but in order to do that, all terms should be on one side of the equation. Then assign function to that one. Write that function is continuous on a closed interval, otherwise you cannot use the theorem. And then show that f has different values with the opposite signs at the endpoint of that interval. Now, 0 is between positive and negative values, and by intermediate value theorem, there should be a number c for which you get 0. But for that number, you get f of x equals 0. So that means c is a 0 of the function. C is the root of the equation, and then C should be root of the original equation. Any question?
Right, so the final answer is n is between f of 3 and f of 2.
F of 3 and f of 2, I just put in order because f of 3 was negative, f of 2 was positive, right? Doesn't make difference if you put f of 2, f of 3. It's f of a and f of b. So n is between those two. Okay, try, I'll leave this one on the board. Do 56. 56 says sine x equals x squared minus x. Show that this one has a root in interval 1, 2. So move to the left-hand side. Let's say sine x minus x squared plus x equals 0. A sine function. Now, f is continuous or not on a closed interval. Remember, see, it's given to you one open interval. You need to look at the closed interval. So you have 56 sine x equals x squared minus x. So sine x minus x squared plus x. And then let so f of x is continuous on 1 to 2. It's a sum and difference of polynomial function and trigonometric functions. Both of them are continuous on whole real number line. So that means they are going to be continuous. On 1, 2. Now evaluate f at 1, f at 2. Now you need to show that they are not equal to each other and at the same times they have opposite signs. So f at 1 is sine 1 minus 1 squared plus 1 equals sine 1 greater than 0. F at 2 is sine 2 minus 2 squared plus 2 equals sine 2 minus 2, less than 0 definitely. So n equals to 0. We have f at 1 not equal to f at 2. N equals 0. N is between f of 2 and f of 1. Now, by intermediate value theorem, there is a C in 1, 2, for which or such that f of C equals to n, which is 0. So C is going to be 0 of f of x. So if it's 0 of f of x, C is the root of sine x minus x squared plus x equals 0, which implies C is the root of sine x equals x squared minus x. Okay, any question? So don't forget, the hypothesis is important. So that means you construct functions. Right, definitely. That f of x is continuous on a closed interval. That's important too. Evaluate f1, f2. You can use calculator to approximate values. It's up to you. You need to get positive and negative values not equal to each other. N is between any positive and negative number as long as n equals to 0. But by intermediate value theorem, there is a C for which we get 0, which means C is going to be solution for the f of x equals 0. It's a root of f of x equals 0. It's a root of the equation, and it's a root of original equation. Okay, any question? No question. Now, number 42, again, go back to the continuity. Go here. So again, interesting problem, and you may have it on your exam. Find the numbers at which f of x is discontinuous. At which of these numbers is f continuous from the right, from the left, or neither? Sketch the graph of f of x. Number 42. Now notice x squared plus 1 is continuous when x is less than or equal 1. It's a polynomial. It's always continuous. 3 minus x is a line. Again, continuous, definitely, on the 1 to 4 because it's continuous everywhere. Square root x is continuous on 0 to infinity, and this one is greater than 4. So it's again continuous. So the discontinuities can happen at the points where the intervals are disrupted. So we're splitting. So at x equals 1 or x equals 4. So those are the points you need to worry about. But we can cheat a little bit. So graph it first. Graph will help you a lot. Because anyway, you have to graph it. So let's start from the graph. So 42 f of x equals x squared plus 1 if x is less than or equal 1. 3 minus x if 1 is less than x less than or equal 4. Square root x if x is greater than 4. So discontinuities may happen at 1 and at 4. We need to find out. So x is less than or equal 1. F of x is x squared plus 1. Grab this one. X 1 is less than x less than or equal 4. F of x is 3 minus x. X is greater than 4. F of x is square root x. Now a few points for each of them. The graph. Now, less than or equal 1, we can choose negative 1, 0, and 1. All of them are included. Negative 1 squared is 1 plus 1 is 2. 0, we get vertex, which is 1. 1, we get 2. So negative 1, 2, 0, 1, 1, 2. So the graph is this parabola. This part is included, closed circle. This one goes this way, to the left. Now for green one, it's 1 through 4, but 1 is not included. Not included, but you need to use it. Then you can choose 2, 3, 4. So when it's 1, 3 minus 1 is 2. When it's 2, you get 1, 0, negative 1. Now 2, 1, 3, 0, 4, -1. See, it goes up to 2, it's open circle, but it's closed because blue one ends at that point. So this one shows, so it continues